Hey, welcome to LabMinutes.com. In this video, we'll be looking at various type of back-to-back T1 that you'll find very useful when you construct your own lab. So on this diagram here, you see we have two routers set up, R1 and R2, that they are connected on the serial interface by a crossover T1 cables. So you see there are two types of WIC that we'll be dealing with here. One is the regular DSU-T1 and the other is a VWIC, which is voice or data type of network interface card. So let's get started. We're going to work our way down from top to bottom here. Started off with just a simple HDLC and PPP type of connection. So, all right. So here's our first router, R1. Alright, we have a serial 010 just to do show diag and give you an idea of what interface we are using here. It is a 1DSU-T1V2, and on the R2 side we have the same kind of interface. So the first part of the configuration will get under the serial interface. By default, it's encapsulation HDLC, so we can type that in as well. Let's put an IP address. We do service module, command T1, clock source, internal. So the router R1 is going to be the one that provides the clock. Source module, we can do frame ESF, T1 actually, frame ESF, line code BSZS, which is the default, so it might not show up in the config. T1 time slot 1 through 24, speed 64. Okay. Let's check and the configuration. The last thing we need to do is no shut, obviously. Let's copy that. The R2 side is going to be very similar, except we're going to do clock source line, which is again by default, and no shut. Make sure we use the right IP here. There you go. Okay, you can see we can ping across the T1 connection here. So let's take a look at the interface. Yep, encapsulation HDLC. And we can also ping from R2 back to R1 as well. Okay. The next part, we're going to try to turn this into a PPP encapsulation. So encapsulation PPP. Encapsulation PPP. Okay. Again, we can ping successfully. So let's look at the interface. So encapsulation PPP. If you look at the under the PPP options, you can see the whole slew of configuration that we can do. We're not going to go through all of that, but there's one thing I want to show you, which is if we do show IP route, you will notice that you have a host routes of the peer, which is 6.2. Okay, this is pretty unique for the PPP. What you can do, just to show you one trick, for the PPP interface, the 2.0 interface doesn't actually have to be on the same subnet. So if you were to change the IP of the R2 to something that's totally on a different subnet, which is, let's try 7.2. Show IP route one time. You can see how it's updated, and you can ping it no problem. Okay, so, let's change this back. Sometime when you want to advertise the serial interface subnet, this static route right here, or the connected route right here, might interfere with your routing. So there's one simple command that you can do to get rid of that particular route. It's a peer neighbor route command. Just do no of that. And just going to shut, no shut. Just give it a second for the interface to come up. Okay, now you can see that the peer IP has disappeared from the routing table. Okay. All right. So let's move on to the next type of T1, friend relay. So let's start out fresh. We're going to do a default 0101 to clean up the interface config. Okay. All right. The first command we're going to do is enable encapsulation frame relay. No shut. Make sure you enable a DCE type interface. So that would be DCE. Same thing, we're going to do service module T1 clock sourced internal. And time slot 124, speed 64. We're going to leave everything at default. So now we're going to go into the sub interface .1, make it type point to point, give it an IP address, assign the HDLC, so pick 16. Let's see what it looks like. There you go. Just going to copy that into our notepad. And for R2, obviously let's see, we don't need clock source internal because we're going to do a source line. And we're going to change the IP. Alright, just to check the status of our PVC, frame relay PVC, now it says active on one side. So let's do a ping, 172.16.6.2. Again, we can ping successfully. And just to make sure, it should be up, otherwise we wouldn't have been able to ping across. There you go, active. So that is it for the frame relay. Moving on to the next one, which is the next network interface type, which is VWIC. Okay. On this router here, we just have the VWIC version 1, which is the VWIC T1. There you go, VWIC T1. If you deal with VWIC 2 or 3, version 3, which can support both T1 and E1, you need to issue a card type command. Obviously, it's not going to show up on this router because we don't have those kind of VWIC. But you will need to do card type command and specify whether you want T1 or E1. But here, since we're using version 1, the only thing we can do is just T1. So the first command we have to do is controller T1. Here's 000. By default, again, line code is going to be B8CS, frame ESF, clock source internal. Now the command is going to be shadow group. We're going to pick number 0. Times lot 1324, speed 64. Okay. Now you can see that 0000 colon 0 has been created for us. So let's get under that serial interface. Get an IP address. Just going to do encapsulation PPP for this one. Okay, we're just going to copy controller T1. And paste that on R2. Now the interface is up. We should be able to ping across. Looks like we forgot to clear the frame relay, so let's make sure that doesn't interfere with the configuration here. Okay. Okay, now we can ping, no problem. To show controller T1. You can see the T1 status for 0000 is up. Alright. So that's completed. The next one is Multilink PPP. And we're gonna use now both of our network interface, which is the DSGT one that we used earlier, and the VWIC, to be a member of the Multilink PPP. First, we'll remove the IP address, and we'll add that to a group. Just select group 1. We'll do the same thing on R2. Now we're going to go back to our 010 and configure that real quick. Now we're going to go under the Multilink interface, give it an IP, 16.6.1. Alright, still set inactive, but that's okay. That's because we have not configured R2. Copy. Now you can see the status of the Multilink interface. It's up, and both members are also up. So at this point, we should be able to ping across the Multilink, which we can. So let's take a quick look at the interface. You can see the bandwidth is now pretty much double. So instead of 1.5, it becomes 3 meg. That's because we have the two T1s bundle. Okay. Just to show you the redundancy that we have here, I'm going to go ahead and unplug the cable from our 000 here. So there you go. So now that's the status become down, down. And it also reflects under the Multilink interface status. But we still have the other interface up, so we should still be able to ping or utilize the remaining link. Yep, no problem. Let me plug that one back in. So that completes the Multilink point-to-point. Now the last type of back-to-back T1 that we're going to look at is for those voice engineers out there, UC engineer. It's going to be back-to-back PRI. Again, let's default the interface. Okay. The first command we're going to do is network clock participate, we're going to tell with 0 to participate on the clock. And then we're going to configure the ISDN switch type. Let's pick a primary NI type. And now we go under the controller T1. Before that we had shadow group command configured. We're just going to remove that. Oh, we still have the Multilink active, so we need to shut and delete. Let's do that in R2 as well before I forget. Multilink shut and delete. Okay. So R1's going to act as a network side of the connection. So go back to controller T1. Instead, we're going to do PRI group time slot 1 through, we're just going to do a full PRI here, so 23. Now it's being created of those channels. And probably one of the most important commands you need to put to make all this work is ISDN protocol emulate and tell that to act as a network side. Okay, so this side should be set up. Now let's jump to R2 and complete our configuration. Controller T1. No shadow group 0. PRI time slot 1 through 23. Oop, we forgot the. Let's do network clock participate with 0. SDN switch type primary NI. Controller T1 PRI group time slot 1 through 23. Okay, so those are created. Let's take a look at our channel 23, which is the signaling channel status. Set down. Okay, let me check the cable on the T1 that we unplugged earlier. Oh, that one should not say source internal, so let's fix that. Okay, looks like there was a loose cable, so now the channel 23 should be up. There you go, up. Let's make sure the ISDN status is good as well. So you can see here, layer 2, it said multiple frame established, which tells us that it's good to go. So let's make sure it said the exact same thing on the other side. Yep. So that's it. That completes our video for our back-to-back T1. Thank you so much for watching, and I'll see you guys in the next video.